We're back, and we're in the new and improved expanded form. How does one graph a polynomial in expanded form? Keep in mind that expanded form looks like something like 14x to the third minus 3x squared plus 2x minus 10. That would be expanded form, right? You're not going to see the factors. You're going to see the polynomial in its expanded form. So let's dig in. Our first function in standard form is negative x to the third plus 6x squared minus 12x plus 8. And so we still have these same questions that we want to answer over on the side, right? For instance, find the polynomial's degree. Well, I know that this is a third degree polynomial, leading me to believe that it should have 3 zeros to account for. Is the lead coefficient positive or negative? Well, that's a negative 1x to the third, so this is negative. Since it's a third degree, it's odd. I know that it's going to look like one or the other. Remember, this is the positive version, this is the negative version. So our end behavior is up on the left and down on the right. The max number of turns that this is going to make, remember that's n minus 1 for max number of turns. So since n is our highest degree, it's going to be 3 minus 1 or 2. So the max number of turns this is going to make are 2 turns. And now enters the work. So recall from earlier that the rational zeros, right, come from factors of 8. So we're going to have plus and minus 1 times plus and minus 8, plus and minus 2 times plus and minus 4. So there are all of our possible zeros. And what are we going to do? We're going to engage in, that's right, synthetic division to figure out who the real zeros are. And so I'm going to go ahead and just give it a shot with 1. So we'll bring down that first coefficient, negative 1. That gives us a negative 1. If we multiply, that brings down a 5. That gives us a 5. That brings down a negative 7. And of course, that's not going to work. Trial number 2, enter negative 1. Drop down to negative 1. That gives us a positive 1. Drop down to 7. That gives us a negative 7. And whoa, that's not going to work. That's going to be negative 19. No dice. Enter positive 2. Now, just for the record, I know that I keep erasing. I wouldn't erase on real paper. I would just use, more space. And it looks like, ding, 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 2 is a 0. Okay, so I have one of my zeros. And then I want to realize that that is x minus 2. This is one of my factors, right? The 0 is the 2. The factor is x minus 2. So now let's see what we got here. Here is our new function that's going to be negative x squared plus 4x minus 4 times x minus 2. So let's just write that down. So what we have is our quadratic term, our linear term, and our constant term. And we have a factor here. So this original function here is now broken down into 2 factors. X minus 2 times negative x squared plus 4x minus 4. Okay. Now going back into some smart factorization skill sets, pulling the negative out of this would be a good idea. So I'm going to put that negative way out in the front. And when I pull the negative out of this set here, that's going to give me a positive x squared minus 4x plus 4, right? It's going to flip-flop everybody's sign. And then I'm going to factor that one more time. I notice that this is a perfect square trinomial, where this is x minus 2 and x minus 2. And I notice that because this end value, the constant, is positive, which means both signs are the same. This one tells me which, means both of these signs were negative. 2 numbers who multiply to positive 4 and add up to negative 4x. So there we go. So it looks like we got negative 2 or I should say a positive 2 is a 0 with a multiplicity of 3. Now, since this is a third degree polynomial, and I have just one 0 with a multiplicity of 3, I know that it's coming down from the top and going down like this. I know that this moment is a flex on the 0. So our x-intercept is going to be 2, 0, right? And our y-intercept, right? Keep in mind, x-intercepts are just all of the zeros written in fancy coordinate terminology. And our y-intercept is going to be the value of x when, or the value of y when x is 0. So when x is 0, all this gets wiped out and we're left with positive 8. So I guess our y-intercept, is 0, 8. Let me clean that up. Okay, so all the hard work's done. All we got to do is just put this on some nice graph paper. All right, so we're just going to come down steep like this and then flex over and down. And that's pretty much a reasonable sketch. By the way, one little thing I forgot to point out is that the factored form of this polynomial was x minus 2 all to the third power, I should say, negative x minus 2 all to the third power. So that's where we get that multiplicity of 3 for a 0 of positive 2. Forgot to add that in. So our next problem, same as the last one, but just maybe the function looks a little different. And really what this is going to come down to is my factoring skills, right? My factoring skills are what are going to make or break me. So there's no constant here. So I notice that there's all x's. So I could immediately factor out an x to the third, which leaves me with x squared minus x minus 12. Well, look at there. That's going to give me x to the third. And then I have a nice quadratic here, right? I notice that my sign for 12 is negative. So that tells me that I'm dealing with a positive and a negative. X times x gives me x squared. And let me see. Two numbers who multiply to 12 and have a difference of 1, well, that's going to be 3 and 4. And I want that 1 to be negative. So the bigger number should be negative. Okay. And so there's our factored form. So how do you graph polynomials when they're not in factored form? You put them in factored form. All right, so what do we have? Once we have this thing factored, the rest of the work is done, right? Find the degree of the following. This is an x to the 5th degree, so our degree is 5. There's a positive 1 right here, so the lead coefficient is positive. That means that our odds look like this when they're positive. So we're going to have as x moves to the left, y is moving down, and as x moves to the right, y is going up, right? That's what we got there. So that's that part. Max number of turns is going to be the highest degree, minus 1, so maximum of 4 turns. The possible rational zeros, there should be, sorry about that, I had the number 4 right there, meaning there was going to be 4 rational zeros. I just blanked out why I wrote the 4 there. I don't need to really worry about the possible rational zeros because this factors so nicely I'm not going to need to do synthetic division, so no need for that. Factored form, right? We dealt with this okay already right here. And now let's get to the zeros. Right here, when I set that equal to 0, I'm going to get a 0 of 0 with a multiplicity of 3. Okay, and then I'm going to take this factor. I'm going to get a 0 and negative 3 after I set it equal to 0. And this factor, I'm going to get a positive 4 when I set it equal to 0. So my x-intercepts are going to be 0, 0, negative 3, 0, and 4, 0. When I put 0 in for x to get the value of y, everything goes to 0. So 0, 0 is also our y-intercept. And now it's all over except for the graphing. And so there we have it. Now, I just want to kind of trace over what I did. I know that I had to come up from the bottom and peak out somewhere here and then come down to 0. When I went through 0, I had to flex, right? So I'm going to kind of accentuate that flex, come down, and I know that I got to end up on the upstroke, and I'm going to go through that number 4, remember, the 4 and the negative 3 are multiplicities of 1, so that means it's going to strike through and strike through. I know that the 0 had a multiplicity of 3, so there needed to be a flex at that moment. I was curious as to how high and low those peaks were. So when you substitute in negative 2 for x, you get a positive 48. When you substitute in positive 3, that's a negative 162. I'm not saying those are actually the official local max, right? Or if that's the official local min. Okay, so I'm just going to put a question mark there. But there is a local max somewhere. There is a local min somewhere. And I'm just trying to accentuate that in the picture. Next graph. Now this one looks like a monster. But again, it really isn't. It's just about having a technique for factoring. So first thing is start breaking this thing down using synthetic division, right? Get in there and start dealing with some multiples of 14. So I know I have an x to the 5th, 4th, 3rd, 2nd, a linear term, and a constant. Nothing missing, so no fancy substitution of zeros. Let's get after it. And let's go with a negative 1 to start, right? I know it's going to be plus and minus 1, plus and minus 2, plus and minus 7, plus and minus 14. So we drop down the 1, we got negative 1, negative 5, positive 5, positive 9, negative 9, positive 1, negative 1, negative 14, positive 14, 0. Bing, bing, bing. All right, we got negative 1. But this is still an x to the 4th, 3rd, 2nd, linear. We need to do this again. Let's go for negative 1 again. See how that works out. 1 times negative 1 is negative 1, negative 6, positive 6, 15, negative 15, negative 14, 14, 0. Looks like we got a multiplicity of at least 2 for the negative 1. I feel like we're at the casino. We're playing hot. We're hot with the number negative 1. Let's try it again, see if we can continue to use it. If there's a flex at negative 1 or if there's a touch and turn. Right, so far we got a multiplicity of 2. So let's see, negative 1 times 1, negative 1, negative 7, positive 7. 15 minus 7 is 8, crash and burn. How about we move on and we try the number 2. Drop down the 1, 2 times 1 is 2, negative 6 minus 2 is negative 4. That gives us a negative 8, that gives us a positive 7, that gives us a positive 14 with a 0. Ding, ding, ding. So we got multiplicity of 2, a turn and burn at negative 1. So far, multiplicity of 1 on the 2. And now this gives us an x squared minus 4x plus 7, which factors to, I know that I see a negative on the 7, or a positive on the 7, and a negative here. This one tells me that there's 2 of the same sign. This one tells me which, so that's 2 negatives. 7 only breaks down one way, and then we got an x and an x. Well, I guess that there are no factors here, which tells me that we're going to have 2 true zeros and then an unfactorable quadratic. So what are we going to do with that unfactorable quadratic? Well, we're going to perform the quadratic formula, our favorite, right? So you got a 1, a negative 4, and a 7. There's our a, b, and c. So the opposite of b, plus or minus, b squared, negative 4 squared is 16, minus 4 times a times c, all over 2 times a, which gives us 4 plus or minus the square root of negative 12. So who's showing up to the party? You guessed it, your good friend I, and I don't mean and poor grammatically me. And at the end of the day, after a little simplification, we end up with 2 plus or minus I rad 3. That's 4 times 3. Pull out the I for the negative. Square root of 4 is 2. Rad 3. Simplify, 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 or reduce. And you get 2I plus or minus I rad 3. All right, friends, so where does that leave us? That leaves us with a polynomial of degree 5, right? It's a positive because there's a positive 1 right here, which gives us n behavior looking like as x moves to the left, y goes down, and as x moves to the right, y goes up. Maximum number of turns at 4. Our possible zeros, right, or our possible rational zeros we started off with were all of the factors of negative 14, plus minus 1, 2, 7, and 14. We had a factored form right here, which tells us that we have a multiplicity of 2 at our 0 of negative 1. And then we have a rational 0 at 2. And then we have 2 imaginary zeros, which means we're only going to hit this thing at the x-axis twice. And at one of those moments, we're going to bounce off of it. And we have a y-intercept at 0, 14, right? The constant down at the end there. And our x-intercepts are going to be negative 1, 0, and 2, 0. Let's graph. And so what do we have? At negative 1, we said that we were going to have a multiplicity of 2, which means it has to bounce off. And at positive 2, it's a singular, so it has to strike through. I know that after 2, it has to go up. I know that prior to negative 1, it has to come from down below. So it must go up to negative 1, bounce off, go through the y-intercept, and then bing, out the door we go. And we're all set. So what do you have in front of you now? Well, some review and some new. So for the worksheet that we have here for you, we want to find the zeros, the multiplicity, all that good stuff. You could read the instructions. This is in factored form, so we can discuss our zeros, and maybe you want to build a little table so that you can keep, what the zero was, what its multiplicity was, and does it cross or touch or bounce, yada yada. Does it flex? What's the degree? At the left end, is it going down or is it going up? At the right end, is it going down? Is it going up? And then a sketch. On this one, again, talking about the multiplicities, yada, yada, yada. But what do we notice? Hey, this guy's not in factored form. So we're going to have to do some synthetic division. And just a little heads up on the synthetic division. There's some pieces missing. So I know I have a 1 for the x to the 4th. There's no x to the 3rd. There's a negative 10 for the x squared. There's no x. And then there's 9, right? So what am I doing? I'm keeping track. This is my 4th exponent, my 3rd exponent, my 2nd exponent, linear, and a constant, right? And then the possible factors of 9, right? Plus and minus 1, plus and minus 3, plus and minus 9, until you get a 0, so on and so forth, and do the best you can on that one. I will say, without giving away the farm, is it does have a very traditional x to the 4th look. One of those sort of describes it. The next one, factored form, right? But there's lots of exponents here, right? You got the squared, a third, a fourth. This is a very high degree program. So interesting drawing for this one. And then your final one is just a simple x to the 3rd, and I think you'll be just fine. And again, this one is a very traditional, odd, I don't want to give it a spoiler alert on which direction, but it's one of those. Good luck, and we'll see you around.